In this video, we will use VisSim Embedded to create and execute models that blink the red and blue LEDs on a Texas Instruments F28069M Launchpad board. The F28069M Launchpad board is a high-performance, low-cost board specifically designed for motor control applications. The board has several features that must be configured for use with VisSim Embedded. First, on the upper corner of the board is the USB connection, which provides both JTAG communication between the Launchpad and the VisSim model as well as power. We'll refer to the Launchpad board as the target and the PC running the VisSim model as the host. The target is connected with the host using the USB cable provided with the Launchpad. Second, the jumpers J1 and J2 must be in place for the board to receive its power from the USB. And third, the three microswitches must all be set in the upward-facing direction. To get started, the target is connected to the host using the supplied USB cable. After launching VisSim, we'll create a model that will blink the red LED at a frequency of 0.5 Hz. From the Embedded Piccolo menu, select and place an F28 config block on the screen. Right-click on the block to examine its properties. First, make sure the CPU is set to our target, the F28069M. Next, make sure the clock source is set to internal oscillator. And finally, make sure the JTAG connection is set properly. The XDS100V2 value is what we're using. Click OK to save any changes. From the Embedded Piccolo menu, select and place a digital output for F280X block on the screen. Right-click on the block and select the type as digital and set the channel to 34 for the red LED. Click OK to save your entries. You will see the GPIO34 label on the digital output block. From the block's Signal Producer menu, select and place a square wave block and connect it to the digital output block. Right-click on the square wave and set the frequency to 0.5 Hz. Click OK to save your entry. Under the System Properties Range menu, set the time step value to 0.01 seconds and the end time value to 1000. Click OK to save these changes. Before continuing, we'll save the model as helloworld.vsm. Now we're ready to execute the model on the target. First, under the Tools menu, select CodeGen and click Compile. Second, acknowledge the DOS prompt by pressing any key to continue. Third, click Download on the Code Generation Properties dialog box. And last, click Download on the Download to 280X block. After the download completes, the target begins executing. You can see the red LED blinking at the 0.5 Hz rate. Now we'll modify the Hello World model to blink both the red and blue LEDs. From the block's Boolean menu, select and place a NOT block on the screen. Control, Shift, plus left mouse button on the GPIO34 digital output block to copy it. Right-click on the block, select the type as digital and the channel to 39 for the blue LED. Click OK to save your entries. You will see the GPIO39 label on the digital output block. Wire the square wave through the NOT block to the GPIO39 block. Before continuing, save the model as Hello World, red and blue. Now we're ready to execute the model on the target using the same four-step procedure. First, under the Tools menu, select CodeGen and click Compile. Second, acknowledge the DOS prompt by pressing any key to continue. Third, click Download on the Code Generation Properties dialog block. And last, click Download on the Download to 280X block. After the download completes, the target begins executing. You can see both LEDs alternating, blinking at the 0.5 Hz rate. Let's experiment with the blink frequency. Right-click on the square wave and set the frequency equal to 10 Hz. Click OK to save your entry. Now we'll execute the model on the target using the same 4-step procedure. Under Tools, select CodeGen and click Compile. Acknowledge the DOS prompt. Click Download on the Code Generation Properties dialog block, and then click Download on the 280X block. After the download completes, the target begins executing. You can see both LEDs alternately blinking at the 10 Hz rate.